Ever thought about how a company builds a modern airliner when its wings are made in one country, its fuselage in another, and its final assembly happens thousands of miles away? It sounds like an impossible puzzle, moving enormous aircraft parts across oceans and continents, all while keeping production on schedule. Yet this challenge led to one of the strangest and most fascinating cargo aircraft ever created. So in this video we take a look at how Boeing solved that problem, how many Dreamlifters are flying today, and why these unusual aircraft are still essential to building the Boeing 787 Dreamliner. When Boeing launched the 787 program in the early 2000s, the manufacturer was not just designing a new aircraft, it was reinventing how commercial aircraft would be built. Instead of concentrating production in one location, Boeing embraced a globally distributed manufacturing model with major components produced across Asia, Europe, and North America. But that ambitious strategy raised a key question. How could the company transport aircraft parts that were simply too large for conventional cargo aircraft? Boeing's answer was to heavily modify the iconic Boeing 747-400, creating the 747 large cargo freighter, better known as the Dreamlifter. With its dramatically enlarged fuselage and swing-tail loading system, the aircraft became a bridge between suppliers and final assembly lines around the world. Today, 4 Dreamlifters are in active service, continuing to play a vital role in supporting the 787 program and standing out as some of the most distinctive aircraft in the sky. The story of the Dreamlifter begins alongside the early development of the Boeing 787. Unlike previous Boeing programs that relied on centralized manufacturing in the United States, the 787 was designed around a global partnership model. Wings would be built in Japan, fuselage sections in Italy and the US, and major composite structures across several other locations. At first, Boeing hoped to transport these components mainly by sea, but early production delays and quality issues quickly exposed the limitations of ocean freight. Shipping by sea could take weeks, while air transport could reduce transit times to just hours, a critical advantage for a program already facing schedule pressure. Rather than designing a brand new aircraft, Boeing chose a faster and more cost-effective solution and decided to modify existing 747-400s. In 2003, the company announced the Large Cargo Freighter program, selecting 4 used passenger 747-400s for conversion. Evergreen Aviation Technologies Corporation in Taiwan carried out the complex structural modifications, working closely with Boeing engineers. The Dreamlifter's radical design immediately became a talking point. Its most striking feature is the massively enlarged fuselage, which bulges outward above and behind the cockpit, creating cargo volume unlike anything else in commercial aviation at the time. Instead of loading through the side doors or a nose opening, the Dreamlifter uses a swing-tail design, where the entire rear fuselage pivots open to the side, allowing oversized components to roll straight into the cargo hold. Inside, the aircraft offers about 65,000 cubic feet of cargo volume, roughly 3 times that of a standard Boeing 747-400 freighter. While its maximum payload weight is around 113 tons, it is optimized to carry large but relatively lightweight components such as 787 fuselage barrels, wings, and horizontal stabilizers. Despite its dramatic transformation, the Dreamlifter retains much of the original 747-400 structure, flight deck, and systems. It's powered by 4 General Electric CF6 ATC2 engines and has a similar range when lightly loaded, though its unusual aerodynamics create more drag, making it less fuel efficient than a normal freighter. For Boeing, that trade-off was worth it because of the aircraft's unique mission. In terms of size, the Dreamlifter measures about 235 feet in length, with a wingspan of 211 feet, the same as a standard 747-400. Its maximum takeoff weight remains close to 396 tons. But the cargo bay's interior cross-section is so large that it can hold an entire 787 fuselage section in one piece, eliminating the need for disassembly and simplifying the logistics chain. Only 4 Dreamlifters were ever built, each converted from former passenger aircraft originally delivered to airlines such as China Airlines and Malaysia Airlines. Today, they're registered as November 249 Bravo Alpha, November 718 Bravo Alpha, November 747 Bravo Charlie, and November 780 Bravo Alpha, and their small number shows just how specialized they are. The first Dreamlifter made its maiden flight in September 2006 and quickly entered service, shuttling components between suppliers and Boeing's assembly sites. There were a few memorable moments along the way. In 2013, one aircraft famously landed at the wrong airport in Kansas, touching down at a small general aviation field instead of its intended destination. The incident drew global attention and highlighted how dependent the aircraft is on long runways and specialized infrastructure. Even with small hiccups, the Dreamlifter proved its value. By reducing transit times dramatically, Boeing could respond more quickly to production bottlenecks and supply chain disruptions. Over time, the aircraft became a familiar, if still rare, sight at key aviation hubs. Operation responsibility for the fleet was eventually handed to Atlas Air, which flies the aircraft for Boeing using its own crews and maintenance teams. Unlike commercial cargo aircraft that fly wherever demand exists, the Dreamlifter operates a predictable but global network tied closely to the 787 production schedule. One of its most frequent destinations is Charleston International Airport in South Carolina, home to one of Boeing's 787 final assembly lines. Dreamlifters regularly deliver fuselage sections and other components from domestic and international suppliers. In Japan, airports like Nagoya's Chubu Sentrei International Airport play a major role because Japanese manufacturers produce the 787's composite wings. Dreamlifters carry these wings to the United States, often stopping in Anchorage for refueling on trans-Pacific flights. Taranto Grottaglie Airport in Italy supports fuselage production, while Wichita Dwight D. Eisenhower National Airport in Kansas frequently sees Dreamlifter traffic carrying forward fuselage assemblies from Spirit Aerosystems. Because the aircraft's missions are so specialized, every sighting feels rare and special for aviation enthusiasts. Routes change with production needs, but the aircraft always connects the same small group of key manufacturing sites that keep the Dreamliner program running. While the Dreamlifter is uniquely Boeing's solution, Airbus has long used its own fleet of outsized cargo aircraft known as the Beluga family. Originally based on the Airbus A300-600, the Beluga entered service in the mid-1990s to support Airbus's distributed manufacturing system. Like the Dreamlifter, it features an enlarged fuselage for carrying wings and fuselage sections, though Airbus uses a raised cockpit and front cargo door instead of a swing-tail design. More recently, Airbus introduced the Beluga XL based on the Airbus A330-200, offering greater payload capacity and volume. Together, the Dreamlifter and Beluga XL show two different engineering solutions to the same logistics challenge, reminding us that building modern aircraft is as much about transportation as it is about aerodynamics. So today, the answer to the big question is simple but surprising. Only 4 Boeing Dreamlifters are in service, yet those 4 aircraft remain essential links in one of the most complex manufacturing systems ever created. Without them, moving massive 787 components across continents would be slower, more expensive, and far less efficient. The Dreamlifter may look unusual, almost exaggerated in the sky, but it represents an important shift in aviation history. It shows how global manufacturing changed aircraft design, how logistics became a central part of aerospace engineering, and how creative solutions can keep an ambitious program moving forward. What do you think? Should Boeing ever build a next-generation Dreamlifter for future aircraft programs? Let us know by leaving a comment, and don't forget to subscribe for more aviation content. See you next time. In addition to our daily YouTube videos, Simple Flying publishes over 150 articles and a podcast every week. Visit simpleflying.com.